Hello everyone, this is the first video of Ensemble tree models and I will use bagging strategy to build the Ensemble tree. So we first need to upload the data and our data is hello, and therefore I assume that you have already set your working directory where your data set is, and then type my data is equal to read.csv and in parentheses and quotation mark hello.csv. And once you run this command, you will see that under environment pane you have my data, 500 observations and 4 variables. And then you need to install packages. Since I installed all the packages, all of them are in active. If you have not, you need to install them. And then to activate the packages, use the library command. So you need caret package, gains, proc, and random forest. Because the random forest package requires that all categorical variables be declared as factor variables explicitly, I am going to use s.factor function to convert the categorical target variable hello and categorical predictor variable sex into factor variables. Therefore, here we are going to enter my data, and you select hello is equal to s.factor, and again my data, and you select hello, and then control enter. Next we will do the same thing for sex, my data, and then we select sex this time, and is equal to s.factor, in the parentheses my data, select sex, and we run the command. Then next we are going to partition the data into training, which will compose of 60% of the data, and the validation, which is 40% of datasets. By setting the random seed to 1, I will generate the same partitions. While you are partitioning the data, you are always using the same code. Therefore, I have a separate R script here that is composed of partitioning the dataset into training and validation. Let's copy paste this command, and then here we paste it. So we set seed 1 because we want to generate the same partitions, and then we create my index, which is composed of 60% of the data, and train set is going to be my index, validation set is going to be the remaining data set. And next we first use the random forest function to construct the ensemble tree model using the bagging strategy. We set in this bagging strategy entry option equal to 100, which tells the function to build 100 single tree models. As there are 3 predictor variables in this data set, we set mtry option equal to 3, which uses all 3 predictor variables in each single tree model. This also indicates that we are using the bagging strategy. We set the importance option equal to true to produce the feature importance information. Again, by setting the random seed to 1, I will get the same results. So let's start with set.seed 1, and next we will use, and next we title our model bagging tree, and here we will use random forest function, and here our target variable is hello, and the remaining is going to be the predictors, and data is train set, and entry is equal to 100. 100 trees are going to be constructed. mtry is equal to 3 because we are using all 3 predictor variables, and importance is equal to true. Let me correct importance here. Now we can control enter. Oh, I forget to run this command. Let's run this, and let's set this and control enter. To display the feature importance information, use the var implot function to display feature importance graphically. We set the type option equal to 1 to show the feature importance in terms of the average degrees or mean degrees in overall accuracy. Alternatively, if we set the type option equal to 2, then R uses the average degrees in the Gini impurity index to compare the feature importance. So let's see, here we are going to type var implot, and here is going to be bagging tree, and we choose the type 1, and then select it, and then control enter. Now you can see under plots pane, the most important predictor variable is sex, as the model suffers the most degrees in classification accuracy if the predictor variable is dropped. The second most important predictor variable is age. Next, we are going to create the confusion matrix by comparing the predicted class membership and actual class memberships of the validation dataset. Therefore, we are going to type the following command. Predicted_class is equal to predict using bagging tree, and then the dataset is going to be validation set, and then control enter. And next we will create the confusion matrix in the parentheses predicted class. This is our prediction, and our actual data is validation set hello, and then we choose +1 because our target class is 1, and then control enter. Now you can see the confusion matrix under console pane. The performance measures show that the bagging ensemble tree model has an overall accuracy rate of 80% on the validation data. If your specificity is higher than sensitivity, that means the model is much better at classifying class 0 cases correctly than at classifying class 1 cases correctly. Next, we are going to create performance charts, which includes the cumulative lift chart, the decile-wise lift chart, and the ROC curve. So the syntax for creating those graphs is very similar for different types of models. Therefore, we're just going to copy paste from the performance charts R script. So here I have a written code. I'm copying this one and pasting here. Here, instead of model, we need to write which model we are using to predict. In this case, it's bagging tree. Bagging tree is our model. And the validation data set we are using, and type probe. Validation set, we need to type here our target variable. In our case, it's hello. And all target variables needs to be replaced by hello. Here there is another target, so we need to replace this by hello. And gains table, again, gains table is constructed by using gains function, and we have to again choose hello here. And now for performance charts, we have here again target variable, which we need to change it to hello. And then here for lines again, instead of target variable here, we need to change to hello. And here for decile-wise lift chart, we need to change target to hello. And then here again, target needs to be changed to hello. And that's it. So let's run the code for the first part and calculate predicted probabilities in gains table. And now you can see the gains table on the screen. And then we are going to run the code for cumulative lift chart. Now under plots pane, you can see the cumulative lift chart. As I said before, our model, bagging tree model, is better than baseline model because the black line is above the red line. Red line represents baseline. And now let's do the decile-wise lift chart. Now you can see that if you select 10% of highest predicted probabilities, your model does better job than choosing 10% of the data randomly from the dataset. So how much better? 2.5 times more chance to find people who can accept your hello offer. And finally, we can get the ROC curve here. The ROC curve is again better than the baseline model because the black line is above the dash gray line. And you can see area under the curve is 0.8607. So this is the bagging model. If you want to get the random forest strategy, what we need to do is we go back to here. This line we need to change to random forest tree. This time instead of bagging tree, here we type random forest underscore tree. and we use again random forest model, N3 is going to be 100, but MTRY is going to be 2, not 3. Because random forest selects a subset of the predictor variables for building each single tree model, we specify the number of predictor variables to include in the subset. In this case, we ask the function to randomly select 2 predictor variables for building individual single tree models. So what else we need to change? We need to change our model too, because it's now not a begging tree, but it is random forest tree. So whenever you see a begging tree, you need to change to random forest tree. And here again we have another begging tree. We need to change to random forest tree. And that's it. So we can run this one now. Now you can see the results. We can run cumulative lift chart. And this is our cumulative lift chart. This is decile wise. And finally, you can get the rock curve. Very similar results. This is how you can perform ensemble tree models with bagging and random forest. In the next video, I will talk about boosting.